Okay, welcome to my first YouTube video. So today we'll be discussing about polynomial division, right? And so in the past few years, I'm guessing if you're doing the IBU or any sort of math at this level, you've learned how to do, I guess, polynomial plus polynomial, right? Or polynomial subtract another polynomial, or even multiplication. There's all these methods, there's those. However, what happens if you're now dealing with, let's say, a quadratic and you're dividing it by a polynomial? How would that work? Well, there is two ways that I recommend that you do this. There is, obviously, polynomial long division. And the way that polynomial long division is pretty much exactly the same way we use long division with, let's say, 4 and 16, The fact that, okay, we check how many 4s are in 1. If we're not going to do that, we're going to check all of it, and it's just 0 and then 4, etc., right? So let's just start away with how polynomial long division works. Polynomial, just to write it for you guys so you understand. All right, so let's just do a quick example, right? Polynomial division. Let's say we're dividing x squared plus 2x plus 4, and we're dividing it by x plus 4. So we want to write it out exactly like we used to do in primary in long division. X plus 4, x squared plus 2x plus 4. And what you guys have to look at is the key points that you, first of all, divide the highest power by the highest power of the divider. So we divide these two. So it was to be x squared divided by x. We know that that should be x, because how many x's go into x squared? That's pretty much the question. And we know that's x, so we put it up here. Now, what we do when we figure this out, right, because we know how many x's go in, we multiply x by the divider in each separate bit. So we're going to have x times x squared, and you put it right below the equation you are trying to divide with. And then x times 4 plus 4x. And what we do is we take away here, put a negative always into everything you figured out and multiplied with, all the things you multiplied with, right? And so you do x squared minus x squared, because obviously negative, which is 0. So those two cancel out. And then we do 2x, because we're looking at the top, negative the bottom. 2x minus 4x, because the negative, don't forget, that leaves us with negative 2x. Plus 4 because of the remainder. And this is just now a cycle. Now I'm going to use another color. We divide this by x. And how many x is going to minus 2x? Well, minus 2. And so now we put it up here, minus 2. And the way we do this, if you don't understand the concept of how many x's go into minus 2x, it is basically minus 2x divided by x, which can also be minus 2x divided by x. And we know that to simplify in a way, if this makes more sense, minus 2 times x over x means that we can cancel out the x's, leaving us with minus 2, like we got here. And so after do that, we do it again, minus 2 times x, minus 2x, and then minus 2 times 4, minus 8. And don't forget, you all put it in a bracket, minus. So minus 2x minus minus 2x makes it plus. So those cancel out because minus 2x plus 2x. And then 4 minus minus 8, which is 8. So 4 plus 8 is 12. Now, crucial part here. When you're dealing with a situation, right, that has a 12, and you're saying how many x's go into 12. If clearly we don't even have the variable of x or any variable that we're using, that means that you cannot continue dividing it. No amount of x's can go into 12. Therefore, the final division of it was x minus 2, like in long division. That's one of the things that got resulted from the division. And this is the remainder. So that's pretty much long division, polynomial long division. And all we do now to structure it is that basically this, what we just did, if we divide them, this results in x minus 2 plus the remainder is still not fully divided by it. And the thing that's not been fully divided by it is x plus 4, because that's what we've always been dividing with. And that is pretty much how you structure it. Now, 4, and just don't forget, you can do this for anything. This right here can be, let me just make some space. This can here also be like x squared plus 4x plus 2. It can be anything. You can use long division for any sort of thing. Now, synthetic division is another way we can divide polynomials. But the key thing is that we need a linear divider or factor, if it's a factor. Now, when we mean linear, we actually mean a polynomial with a degree of 1. So, linear. So, x plus 1, x plus 4, x plus 3, 2x plus 1. All this type of things, right? It just can never be above x. So, it can't be x squared or x minus 2 or x minus 1, etc. So, what we do here is, let's say we're given a factor, or we want to divide it by x plus 1. And you divide x plus 1, and the actual equation is this. And we're dividing it by x plus 1. Well, we look at the divider, bring it to the side, and we equal it to 0. That gives us x plus 1, take it away, negative 1, so x equals minus 1. Now that we know this is effectively the number we're going to be using for a while. We make a table just like this, and in this part of the table, we always put that number, minus 1. Now here, don't get tricked by it. What we do here also, after that, is that this quadratic, or any polynomial, we use the coefficients and write them in here. So, in x squared, we have 1. And 4x, the coefficient is 4. And then the constant is 2. Now, after we've done this, we bring down the 1, pretty much the first coefficient. We always bring it down. Always bring it down to the first one. We never multiply it by this. This is not multiplied by it. It does not work like that. And we do not want to do that because it creates easy mistakes. Okay, and once we've done that, we have minus 1 times minus 1. So once we bring it down, multiply it to this, and we get minus 1. And we bring that minus 1 that we multiplied it with here. So once we get that, minus 1 times 1 equals minus 1, that goes here. And then we use addition. So this is always being added. Two numbers are going to be added here. So here in this case is 4 plus minus 1, which is 3. And we bring down the 3 here. And then after this, we basically do the same cycle again. 3 multiplied by minus 1 is minus 3. And so we bring it here, minus 3. 2 plus minus 3, it's minus 1. Now, attention. This should always be 0 if you want it to be a factor. So if you want this to be a factor, like in a factor's form, let's say we have x squared plus 4x plus 4, right? And you want it to be in the factored form, which is like this. If you are dividing and this does not end up as 0, that means that it's a remainder. This is a remainder if not 0. Now let me explain why. When we divide, we're going to go down a degree. So the result is not going to be x squared, because that wouldn't make sense if we multiply a power of the same polynomial that we're dividing with the divider, because we would have a greater power than the original. So we go down. So if we always look at here, okay, x squared, and we take away 1. So we have x. And so the first coefficient will have the power of x1. So x1. And then the next one, obviously, we remove another 1. And if x to the power of 0 is 1, there is no x. And it's just a constant. So therefore, x plus, because obviously there should be a plus here, 3. And the minus 1, remainder, minus 1. Therefore, when we divide x squared plus 4x plus 2 by x plus 1, we get x plus 3 minus, don't forget because it's minus 1 over x plus 1. That is what polynomial division works like. Thank you.